So here we've got another 30, 60, 90. We know the hypotenuse is 10, which means the short side is half of that. It's 5. The long side is 5 square root of 3. Since this side's a 45, 45, 90, the two legs have to be the same. So if that's 5 square root of 3, so is this. Then for the hypotenuse of a 45, 45, 90, you need to multiply by the square root of 2. So this is going to be 5 square root of 3 times the square root of 2. When you're multiplying square roots, you just multiply the numbers inside. 3 times 2 is a 6 inside the square root. Five-foot tall girl is flying a kite at an angle of elevation of 60 degrees. The string of the kite is 40 feet long. How high is the kite above the ground to the nearest 100? So we've got the girl. With a kite string that is 40 feet long. The angle of elevation of that kite is 60 degrees, so fill that in with 60 degrees, which means this is 30 degrees, which means we have a 30, 60, 90 if you wanted to make this a little bit easier. It says that the girl is 5 feet tall. So if we were trying to find out, I did not draw this to scale, and it's actually a little confusing because the 60-degree angle I drew, it looks like the 30-degree angle. So let me resketch that real quick. So now it's a little bit better because it looks a little bit more to scale. So if this side is 40 feet, the hypotenuse is 40 feet, we're trying to find the height of the kite. So since it's a 30, 60, 90, we know the short side is half, and the longer side is times the square root of 3. So the height from the top of the girl's head to the kite is 20 square root of 3, and then she's 5 feet tall. So the total distance from the ground is that 20 square root of 3. That's the height above her head, plus her own 5 foot tall. So 34.6 plus 5 feet is 39.64. feet. If you didn't remember the 30, 60, 90 shortcut, then you just do sine or cosine and solve it out. That's okay too. Person standing on a building that's 150 feet high. The angle of depression of the car from the building is 30 degrees. What is the distance from the building to the car to the nearest hundredth of a foot? So the building is 150 feet. So we can put that over here so it's in the triangle. And we're trying to find the distance from the building to the car, which would be that side of the triangle. So if that's the 30-degree angle, this is the short side of the 30 degrees, or of the triangle. So 150, the leg then, the longer side, it's just going to be times the square root of 3. Or you could do sine if you, or tangent in this case, if you didn't remember that. Times the square root of 3. To the nearest hundredth of a foot. $259.81. Like I said, if you didn't remember the shortcut, you just do opposite over adjacent. And solve that, you get the exact same answer. The end of one ramp is raised to the back of a truck that is 4 feet above the ground. So this is 4 feet. The length of the ramp is 9 feet. What is the measure of the angle the ramp makes with the ground? So what's the angle right there? We have the opposite side, we have the hypotenuse side, that's sine. So to solve for the angle, we do inverse sine, 4 over 9. So our angle is 26.39 degrees. It's the measure of the angle. 26.39, you could round that if it told you what to round to. Otherwise, it doesn't really matter. You're trying to find the height of a mountain. You're standing 0.4 miles from the center of the mountain, and you estimate that the angle of elevation is 50 degrees. You use tangent 50 degrees and right triangle trigonometry to find the height of the mountain. So we estimated that this is 50 degrees, and we estimate the height of the mountain right there, knowing that we are 0.4 miles away. So let's convert that to feet, because once our answer in feet. So 0.4 miles in feet means you do 0.4 times 5,280, because that's how many feet are in a mile. $2,112. So this is 2,112 feet. So you estimate that the height of the mountain. So by doing this, you get that opposite over adjacent, so tangent 50. Opposite is x over 2,112. And then you solve this by multiplying 2,112 times tangent 50. And we find that the height is 2516, make that be 2517. Then it goes on and says, if your angle of elevation estimate, since it says we just estimated it, was off by 1 degree, what change in the mountain's height is caused by the small difference in angle measure? So 1 degree off by 1 degree means we could be off by 1 degree and it could be 49 degrees, or 1 degree higher than that would be 51 degrees. So we set up the exact same question, just change out those two, or change out the degree twice. And we solve each of those the same way. Multiply by 2112. So when we do it with 49, we get 24, round that up, 2430. It says round to the nearest foot. And if we do that same thing, but with tangent 51, we get 2608. So there's our three different measurements. If it was 50 degrees, or if we were off by 1 degree either direction. But the exact question doesn't say what are the three height measurements. It says if your angle of elevation was off by 1 degree, what change in the mountain's height is caused by this small difference. So if it was off by 1 degree too small, we would subtract 2517 and 2430. That's a difference of 87 feet. And if we had 1 degree too large, if we went to 51 degrees, then we would have 2608. Minus the 2517. And we're off by 91 feet. So we're either somewhere between there, 87 feet smaller or 91 feet larger. Some older review questions. I think it's from the last framework. The movie screen is 8 meters wide and the film is 80 millimeters. What's the scale factor of the projection? So 80 millimeters, we take the original 80 millimeters over 8 meters, which is 8,000 millimeters. You get 1 to 100. So, wrote that backwards though. You take the image over the pre-image. So you got 100 is the scale factor. Triangle A prime, B prime, C prime is the image, so the after. ABC and the dilation was 1/2. So that means A prime, B prime, C prime is smaller than ABC because the scale factor was 1/2. So the angles of ABC are congruent to the angles of A prime, B prime, C prime. That's true. The angles don't change when you dilate. The angles of ABC are half the measure. That's false. We just said the angles don't change. Which means C is also false. The angles don't change. The side lengths of ABC are half the lengths of A prime, B prime, C prime. No, the side lengths of AC are bigger. So the side lengths of A prime, B prime, C prime are half the length of the sides of ABC. That's true. And the two triangles are similar. Yes, dilations make similar figures.